Okay, two sample z-test. We're going to do that one first. The worksheet. So two sample z-test. Can I borrow somebody's? I don't have one. All right. So number one, a sample of the eating habits of high school football players were measured 2 years in a row. Um, wow, that's bad grammar. It should be is or was. A sample was measured. Look at me. 2 years ago, 2 years in a row. In the first year, the 400 players were sampled, and they ate an average. Wow, this is awful. An average of 1,360 pounds of food with a standard deviation of 261. So D is 400. My X bar is 1360, and the SD is 261. The following year, oh, oops. The following year, 625 were sampled with an average of 1320 and a standard deviation of 306. And the question is, did these football players eat fewer pounds per person the second year? So we need to set up our hypothesis, and you can actually set it up however you want. Um, so my null could be that the difference equals 0. There's no difference. And let's put difference. My alternative is that the difference is greater than 0, meaning the first year they ate more than the second year. Or is it up to chance variation? So in order to do this, I need to create SEs. Which SE do I want to make? SE average, so I use the shortcut, and I just divide this by 20, because that's the square root of 400. And I divide this one by, or the SEP. We try to stay away from the SEN. The only time you need to use SEN is when you're doing sum. Or if you're counting, you can do the SEN, but you can change it into a percentage. So this late in the game, it's going to be SE average or SEP. The SE sum won't happen very often. Okay, what do I do with those numbers once I calculate them? I need the SE difference, which is the square root of this squared. So I can calculate it all at the same time. The square root of 261 divided by 20 squared plus 306. I need a parenthesis. So, do you know what a single parenthesis is called? We say it wrong. Parentheses, those are plural, meaning two. A single is a parenthesis. It's a Greek, it's like thesis. Thesis is singular, theses is plural. Or hypothesis, hypotheses. So we say parenthesis, it's wrong, but that's how everybody says it. So I'm just going to keep saying it wrong. All right, SE difference is 17.89. What do I do? Need the z-score. So 1360 minus 1320 is 40. Then I take 40, divide it by the SE difference, and I get 2.23. That is my z-score. So if I shade norm, and I go out here to 2.23, how much area is going to be over there? Less than 5%. How come? What's it's bigger than 1.64. Right. So the difference is significant. So we reject the null and we accept the alternative. It it seems to us that the team ate or the players ate significantly less food than they did the year before. Okay? It'll be like the 22nd, the very last day we're in here. I'm going to put the final as far back as I can. Yeah. Right. That's just to that's just to see if they're going to print the program with your name on it. Yeah. And if we're ready before then, we'll take it before then, but I don't know that we will. Then you probably might as well take it right now. No. Okay, number 2. A sample of 144 Castledale residents and 225 Orangeville residents is taken. So D is 144 or 225. 80, so the total, 80 males and 117 males with an S, or we don't have SDs. Is it safe to say that Castledale has a higher percentage of males than Orangeville? So we need to find the percentages. 80 divided by 144. So 55.5%. And 117 divided by 225 is 52%. What about the SDs? I don't have an SD. So I make a box, and it's 0.55 repeating ones and 0.44 repeating zeros. So I do the SD shortcut. The square root of 0.5 repeating times 0.4 repeating. So the square root of, and I would just put a whole bunch of 5s and a whole bunch of 4s. And both of those are so close to 1/2 that the answer is going to be 0.499 or something similar to that, 0.498. So I got 0.497. So the SD is 0.497. Okay, so now I need an SEP. Oh, well, I need it. And the other one's also going to be 0.499. That's the square root of 0.52 times 0.48. Okay, now what do I need? SEP, so that I can create an SE difference. So the SEP is going to be this divided by 12 and this divided by 15. So I'm going to take 0.497 and divide it by 12, which is 4.14%. Okay. And then 0.499 divided by 15 is going to be 3.33%. Now what? SE difference. Nope. You square them, add them together, and take the square root. So the square root of, and this one, last time I plugged it all into my calculator in one step. When you're using percentages, that's harder to do because you have to convert the decimals into percentages. So you can't really do that little shortcut that I did before. So 4.14 squared plus 3.33 squared. And I get an SE difference of 5.31. Do I have that poster up there? I do. Okay, now what? Need a z-score. 55.5 minus 52 is going to be 3.5. divided by 5.31. And I get a z-score of 0.7. So if I draw my curve, and I'm over here at z equals 0.7, how much area is going to be to the right? A lot, right? Where is the 5% mark? Z equals 1.64. We're less than halfway to 1.64. So there's probably something like 12% in this tail, which means we accept the null and we say there is not, we didn't, but the null would have been there the same and the alternative would have been there different. So we accept the null and we say there is no significant difference between the percentage of males in Castledale versus the percentage of males in Orangeville. And we can only say that because it's a sample. If we actually talked to everybody, we wouldn't do a z-test because we would have a population and there's no reason to run a statistic. So from our data, we are not confident that the percentage is different. But because we only sampled a portion of each city, we do not believe that there is a significant difference, or sorry, there is not a significant difference between the percentages, which means they very well could be the same because of chance error, because of our sampling error, or sampling chance error. Okay, last one. The height of 100 women in Colorado and 196 women in Utah is taken. The Colorado women average 54.3. So D is 100 or 196. And the X bar is 54.3 or 53.7. An SD of 3 and an SD of 2.7. Okay. So we need to create SE averages. So I'm going to divide this one by 10 and divide this one by 14. 0.3 and what is 2.7 divided by 14? 1928. We take the SE difference, so the square root of 0.3 squared plus 0.1928 squared, and that gives me 0.3566 as my SED. Now I take the difference. How far is 54.3 from 53.7? 0.6. So I'm going to take 0.6 and I'm going to divide it by 0.3566. And I get a z-score of 1.68. So here's our 0, 1.68. Let's actually shade norm and see what we get. We know what the answer is, right? We're going to reject the null. But let's just see how close it is. And I get area is 0.0. It's not showing me. Undefined. Wonder if I got an equation in here. So the null would be, they're the same. And the alternative would be, yeah, Utah is shorter. Okay, 0.0465. What does that mean? So the null does not always match up with the question. The null is always equal and the alternative is not equal. So the question and the null don't have to be stated in the same thing. So here we get a p-value of 0.46, which is less than 5. So we reject the null, which said they're the same, and we accept the alternative, which says Utah is shorter. Now the question asks, are we safe to assume that women in Utah are shorter than the women in Colorado? Yes, there is a significant difference between the height of Utah women versus the height of Colorado women. It's not um, it's not highly significant, and it doesn't even tell us how short the women in Utah are. But we are pretty confident, right? We're 95% confident that the average height of women in Utah is less than the average height in Colorado. But we don't know how short they are. We just think they're shorter. Does that make sense? Because we rejected the null.